Good afternoon and a very warm welcome to everyone for the today's webinar on print large or print many with new Stratasys F770 3D printer. So today's webinar will be presented by Mr. Ganesh Babu, who is our mm, General Manager in Applications and Additive Manufacturing. He sits at our Bangalore office. So to tell more about our speaker, Mr. Ganesh Babu hails from Bangalore and is a graduate engineer. He has been professionally serving Indian industries at various capabilities over last 3 decades, working at various capacities from design to manufacturing and to productionize parts and products. He has held various senior positions of management associated with subtractive and additive manufacturing technologies. With additive manufacturing, he has had the privilege of being the first Indian to extensively work on SGC resin-based additive manufacturing technology from Israel and has been handling business development of Stratasys AIM technologies from the year 2000 onwards. So to tell more about this GoToWebinar tool, as of now, everybody will be on mute. We will have the question and answers at the end of the webinar. Also, there is an option of chat window. You can just type your questions over there, or also there is an option to raise your hand. You can just raise your hand and we can unmute you and you can directly ask any query, any questions to Ganesh sir at the end of the webinar. Also, after the webinar is over, I will be sharing the webinar recording and the PPT of slides on your registered email ID tomorrow. So over to you, Ganesh sir. Please take it ahead.
Thank you, Pranjal. A warm welcome to all of you who have joined us today. And it's a pleasure to present to you all on Stratasys F770 for printing large parts or nesting multiple parts to have print many. So here we are going to focus in terms about what Stratasys product line is all about. But well before that, for all of you, I would request you all, you can raise your questions in the chat box or post the presentation. You can unmute and then ask your questions. So let me begin. First of all, today on behalf of Design Tech Systems, like we take pride in presenting to you all today's webinar on Stratasys product line in brief, and then to take you through with the F770 product line of Stratasys FDM technology. First of all, on the business verticals, a brief overview in terms of Design Tech. We are VARs for CAD/CAM, CAE, and PLM solutions, as well as additive manufacturing technologies. Apart from that, we have a very strong engineering services domain, which caters to product design and development services. And then we have augmented reality and mixed reality experiences in our product line. And we are glad to keep you all informed that we completed 26 years in the Indian industry, catering to India as well as to overseas projects in terms about our services. And many thanks to all of you customers for giving us the opportunity to serve you and keep going strong. So well, today's agenda to begin with on the 3D printing solutions, we are going to look at Stratasys. Stratasys is the 3D printing solutions company and its additive manufacturing technologies. We'll have an overview of AM technologies that Stratasys offers and focus more on the F770 large format 3D printer. Here we are going to look at the real FDM from Stratasys. And I'll explain to you all in terms about what are the other competitive technologies and what challenges we come across in comparison to F770, the large format FDM printer from Stratasys. And a brief touch base on manufacturing applications for large or small parts. So we are going to look at print to perform applications of consumer goods, more importantly, customer case studies. And then we get on to the FDM or the F770 discussions. So well, let me begin with the Stratasys introduction to you. Stratasys, the 3D printing solutions company. Well, while we look at additive manufacturing, Stratasys has been the first choice polymer-based 3D printing company. While we look at Stratasys, almost 35 years in the industry now, Stratasys invented the FDM technology. And well, from the invention of FDM, today there are 5 different offerings that we are looking at as multiple technologies that completes the entire polymer-based product portfolio of additive manufacturing. Today, each technology that you see, the 5 technology offerings complement each other. But predominantly, there is exclusivity when it comes to certain technologies where we can beat any competition hands down. So I'll talk about all these 5 technologies in brief to y'all. So well, what makes Stratasys world leaders is to also emphasize not just the 3D printing hardware that comes along as technologies, but they are well complemented with the materials and the softwares. So while we look at the material partner ecosystem, today Stratasys offers world-class outputs. Today we are looking at using 3D printers for batch production, for manufacturing end-use parts. Well, thanks to all the material partners in the ecosystem who have supported Stratasys in their endeavor to elevate the capability of additive manufacturing beyond prototyping. That's exactly where the focus is. And when it comes to the processes, the softwares that process your digital data and to submit the process data to the printer, we use softwares. So these softwares are again a complementing tool that goes beyond the limiting factors of what the input data is all about. So files get corrected for any errors during file transfer process. You would be able to add value in terms of beyond prototyping applications. So well, a whole lot when it comes to the software platforms that come across all the 5 different technologies. So well, Stratasys has not only been very well accepted by the Fortune 500 companies that we look at, or beyond that, the industrial scale that we are focusing on, but well, even the software giants like Google or various other software manufacturing companies are using Stratasys additive manufacturing technologies for the product developments. So well, with this introduction, let me take you through with the introductory video. So Stratasys, while we are talking about why Stratasys 3D printing, here the focus is like Stratasys has been continuously engaged with their customers to analyze the challenges, to analyze the needs in the ever expanding market where manufacturing has scaled up greater heights. So no more looking at subtractive with the limited possibilities. So you have the design freedom to work with, understanding customer needs on what exactly they are supposed to deliver and what is that which is holding them back. Stratasys has been working on various projects with various customers, thereby newer technologies, newer materials get introduced. So well, with 22 plus years in the Indian industry, Stratasys, while we look at education, automotive, healthcare, consumer products, or aerospace and defense, these are a very, very small list of names that we have captured here on this particular slide, but there are many, many more in every spectrum or every given vertical from design to manufacturing domains. So we all know as an additive process, 3D printing today has evolved. Unlike the subtractive technologies where the limiting factors designed for manufacturing, our focus on additive manufacturing today is to print what is desired rather than remove what is not required and retain what is required by the subtractive process. So ideally what I mean to say here is you add whatever the layer detail calls for, you add materials layer upon layer to add materials so that you finally get the design intent or the output from the design, which is called as a digital data or a CAD file. So well, before getting into the details of what Stratasys product lines are, like this slide talks about the 5 different technologies that Stratasys offers. These are world-class, best-in-class technologies. So while we look at Polyjet on the far left, well, it's a cutting edge technology today. We talk about using liquid resins as raw materials. While combining liquid resins, you have the privilege of getting high fidelity models, which means you are having every detail captured when you 3D print, whether it is going to be the textures, the text, the details of the product in colors, gradients of colors, rigid to flexible combinations of materials, opaque and transparent materials, unlimited possibilities. So, well, it's very well been used for various design as well as manufacturing applications. But when it comes to the focus of medical applications, we have exclusive PolyJet printers for anatomy printing. And when it comes to the fashion industry, today, the evolution of PolyJet from Stratasys meets the most ever expanding demands of what the fashion designers need. So you can print on any given part, cloth, whether it is metal, glass. So you print on a given material and add versatility with three-dimensional printing of pixels. So stereolithography, single material resin, has a great acceptance when it comes to making large parts, and more importantly, with industrial grade materials, you'll have tooling as well as molds for various applications from SLA. And the origin P3 in the middle is exclusively a P3. We use the term programmable photopolymerization with the origin 1 P3. So as a programmable technology, it's the best fit for batch quantity manufacturing. It's a DLP process, digital light processing. Well, SAF stands for selective absorption fusion, which is powder bed fusion redefined. Again, high volume production. Here is a system that can cater to make productivity of parts. So you don't invest in any tooling. You straight away use additive manufacturing to get your batch quantities manufactured. Ideally, the best fit when it comes to polyamide materials, nylons, and polypropylene. And what has evolved in powder bed fusion is true to what customers' challenges were. To address those challenges of customers using powder bed fusion, today we have SAF from Stratasys that can print highly intricate and more demanding geometries made with quality as well as high dimensional accuracy that can be taken up as end-use parts on various products. Finally, we have the industrial FDM. So, well, industrial FDM not only for prototyping, even for beyond prototyping applications. So we are going to focus on the industrial FDM because the F770 to print large or print many. Today, the subject of focus in this webinar is going to be on the F770 product line. So let's deep dive into understanding more on FDM technology. Well, before that, I have Stratasys introductory video for you all.
Stratasys is shaping the world around us. From 3D printed rapid prototypes and design freedom, to manufacturing innovation and production-ready solutions. We believe that what starts with a spark of an idea can now become reality. We see opportunities all around. The products, solutions, and services being developed within our walls today are changing the way things will be imagined, designed, and made tomorrow. Stratasys 3D printing solutions allows us to tap into the unlimited imagination and potential within each of us, helping designers, engineers, and manufacturers transform their capabilities and accelerate their progress across virtually every industry. Stratasys is shaping young hearts, planes with purpose, helping explore the next frontier, accelerating progress, manufacturing earth-friendly efficient designs, and delivering power and energy to the world. Stratasys empowers the dreamers to dream, inventors to invent, doctors to heal, and industry to grow. We are shaping innovation, creativity, discovery, education, imagination, and the possibilities of tomorrow. Stratasys, the 3D printing solutions company.
So, well, that was the introductory video in terms of Stratasys. Well, you would have been able to really get a glimpse in terms about the various verticals, starting from education, going up all the way to medical. So it's always there with the automotive and the aerospace verticals. That 3D printing has been very well acknowledged and received. However, let us also look back at what the subtractive manufacturing process is all about. You know, there are quite a lot of advantages when it comes to the subtractive process, but we also need to remind ourselves about certain disadvantages. Well, subtractive process is definitely a true fit when it comes to high volume production. High volume production in terms of our tooling or manufacturing of parts and products. And you also have a wide range of materials. So there are a variety of materials for the manufacturing of various parts and products. But what are the disadvantages? Longer lead time. More importantly, you need special tooling. Also, you have to be a design for manufacturing has to be made. It's a limiting factor. And more importantly, it's not a single step process. It's a multi-step process in the subtractive manufacturing. And more importantly, when we talk about lightweighting, remember this. You would not be able to lightweight a part. Lightweighting is a big challenge in the subtractive process. It's very difficult to achieve. And thereby you have to compromise in terms of strength and stability of a manufactured part in subtractive process. Let's look at advantages and disadvantages of additive manufacturing. Well, I take privilege to present these two slides more importantly to connect with what the existing traditional processes are. However, we need to also know the advantages and the limitations when it comes to both the processes. So in the additive process, we are going to look about unlimited design freedom. So there is no limiting factor in terms about being creative. Designers have unlimited freedom to design and conceive what they need. You will be able to integrate your components. In the additive process, integrating components, electrical or metal fittings, all these are possibilities. You also have a flexible supply chain. And more importantly, without tooling, directly from a digital CAD data, you'll be able to make batch manufacturing made possible and in quicker turnaround times. You don't need an inventory. You don't need to stack up production parts, unlike the subtractive process. And let me reiterate, in additive manufacturing, it is most simplified to achieve complex internal honeycomb structures. Unlike the subtractive process, additive gives you lightweighting of designs, lightweighting of parts, subjective to the next level of application. But there are also a couple of limiting points that we need to take note of. Well, there is not a wide spectrum of materials that we get from subtractive processes, but we are complemented with what is needed for the industry. So we have limited materials that complement every demanding application. More importantly, however, there can be quite a lot of context in terms about looking at manufacturing as a more mature technology. Well, it's more matured when it comes to high-end applications of productivity or performance. But nevertheless, additive has always been neck and neck fighting for performance-based outputs that are rolled out. Now, let me take you through with what FDM is all about. FDM stands for Fused Deposition Modeling. While we look at FDM as a technology, we have printers that could print more than 24 different types of thermoplastics. Well, the classification of these printers are based upon what are the type of materials that go in and what applications do they really serve. That's exactly where we are focusing on. from small to large. But today, our focus on the production-based systems of the Stratasys FDM, that what you see as images here are, these are closed chamber, heat enclosed chambers these are. And they also have vacuum enabled build sheets that are held. So vacuum enabled heated chamber gives you the edge as a patented technology which has been introduced by Stratasys. FDM is far superior when it comes to its throughputs. So what is the process? Let me explain to you about the process. The process of FDM technology begins with, as you see the schematic, there is a model and a support cartridge. These are cartridges which have filaments, and these are thermoplastic filaments. These filaments are being driven by drive wheels into a liquefier zone through which there are tips positioned. So only for a short height or a short length, you have the filament from a solid state getting into a semi-molten state. And through the heated tips, there is an extrusion principle to lay out layer upon layer material. So what happens here with the support material, predominantly on most of the Stratasys FDM materials, you have soluble support, which gives you an hands-free support removal process. So the tips, when they extrude, they can extrude layers as low as 127 microns or 0.127 of a millimeter. And on the larger printers, we have up to 0.5 millimeters, 5 different layer thicknesses to work with. So, well, this is a brief in terms about what the FDM process is all about. Material cartridges that come along with filaments that are wound in spools, and these are sealed cartridges which are read by EPROMs. So the machine could read what is the grade or type of material that has been loaded and what is the content of the material that is there in the cartridge to complete a job. So all these are available for you well before you start the print. With the user interface, you'll be able to read all these available data of material, the temperatures and so on. It's highly user friendly, very quick to learn, and these are workhorses that go unattended during the print process. Now, industries adapting additive manufacturing. I think I need to talk about this because when we look at it in a snapshot, yes, we know that aerospace, automotive are quite a lot, but when it comes to design firms, entertainment industry, architecture models that can be made, oil and gas are more demanding industries where FDM can support you with exclusive materials that perform well when they are in contact with oil or gas. And yes, we have the medical applications exclusive from Stratasys product line. So a whole lot, and it keeps adding on. There's no limiting factor when we look at the industry adaptation to additive manufacturing. So let me shift focus and let's look more in terms about the industrial grade of F770. The industrial grade of 3D printer that we're looking at that caters to a simplified way to make large parts, or you have to have multiple parts that you would like to nest or stack, can all be done because you have a very, very large print envelope. Let's see what we have in the offering to get to know more on the F770. So, well, before we get into understanding on the F770, there are certain market challenges. While you look at limited budgets for large parts, yes, customers do have all these challenges. You need large jigs and fixtures, you need more reliability in your systems, and more importantly, you need to have shorter lead times that are cost effective to produce. So looking at all these market challenges with limitations in budgets and the current systems or processes that have been followed by industries are unreliable, and moreover it takes more time or more cost. End use parts are not functional because of limiting factors in terms of material availability with the low end printers, and there's a whole lot here. So some of the challenges that have been listed here. Now let us look at traditional manufacturing pain points as well. Supply chain issues. You need required skill sets, advanced skill sets It's not just plug and play. You need to generate programs. You need to have a proper choice of material, and the limitations in terms of manufacturing, geometry limitations. And with large format FFF printers, we use the term fused filament fabrication through the large format printers. They are non-reliable. You keep tinkering on to achieve even one part right. Low quality, parts have defects. And limiting factors here are they don't offer you the solution to work with soluble support materials predominantly. And when companies are outsourcing parts, more importantly, longer lead times and outsourcing costs are too very high. And what about intellectual property? There is a risk. Confidentiality aspects are definitely cannot be governed because when you go to third-party resources to get physical prototyping made. So looking at all these challenges, what does F770 as a solution provide? You can print large parts in a single shots, quicker turnaround time, parts on demand technology, that is FDM for you. No need for having your injection molds made. You can get to produce your parts from day one itself. And more importantly, you have the state-of-the-art connectivity with these printers. You'll have your workflow, and you can also start working along in terms about the workflow that you have channelized for your entire team. So today, when we look at F770 versus the FFF existing large printers, industrial grade, it has been proven by Stratasys, right? So we talk about a precision controlled build chamber. So precision controlled build chamber, as I mentioned earlier, with heat, vacuum, materials, and the software that gets aligned with the hardware, all these complement to give you the best or the improved part quality. Heated chamber calls for layer to layer addition, which means there is no curling, no challenges of warpage, and more importantly, you don't have any limitation when it gets to printing any complex geometry at ease. That's exactly what F770 is all about. So companies outsourcing large parts is where exactly they have the value to work along with, to working with your most complex and most demanding design ideas to be rolled over very, very quickly. So lead time reduction, no more outsourcing, and more importantly, your IP is protected. So introducing a large format printer at a lower price. Remember this. The affordability factor on the F770 today, you can conveniently own this printer and get to realize large parts of multiple part printing that can happen. So what is the F770 all about? We are going to look at the complexity of this particular geometry. We'll talk more about what this complex geometry is, where it is going to be applied, and what the challenges in 3D printing are, or in comparison to traditional manufacturing or by any other additive process, what are the limiting factors? We will definitely look at down the slides coming, but well before now, ABS is what the generic thermoplastic that we all use in our day-to-day life, and this part has been made with ABS M30. Now let us shift focus on to understand a little bit more on the machine itself. So you have a print envelope, or the build area that we talk about is very large, 1000 millimeters by 610 on the Y and 610 on the Z, which means it is the largest in terms. So when you recall the largest machine image when I introduced FDM, or when I started with FDM, the F900, well, the F770 is much, much larger in terms of the build volume. It is the proven Stratasys technology. You have the heated chamber. So with the F770, you have 0.178 of a millimeter or 0.254 or 0.330 millimeter layer thicknesses that you can selectively choose subjective to the geometry size and the intricacies involved. Ease of use. Well, today it's a touch screen based intuitive operation. You have GrabCAD as well as Insight, the most customizable software from Stratasys for FDM applications that you have Insight. These two are high-end today in terms of processing your CAD data. You have advanced features for tooling. And quite a lot to talk in terms about mobile monitoring, remote monitoring. When you have a large print over the weekend and you're monitoring how the printer is performing wherever you are remotely, you would be able to have access to study on the status of what's happening. And the manufacturing floor ready connectivity, and more importantly, functional materials. Yes, they come in large 200 cubic inch of materials in either the model or the support. The ABS and the ASA are the two materials that come along with the F770, and predominantly for all standard industrial grades of thermoplastics, we use the styrene based ASA for outdoor applications and ABS for predominantly for every given consumer goods manufacturing or for standard polymer based outputs, a very widely used choice. And let's remember, these are proven materials manufactured by Stratasys and supplied that don't limit you in terms of realizing what the dimension or the performance of a given geometry is. Here's the virtual video of the F770 in terms of the printer. So there you go, like you would have had a virtual tour of how the machine is and how the process of printing begins with on a build sheet. Well, it's a huge platform to really enable you to have the best of large format printing or have multiple parts that you can nest and start printing. So technical innovations which have been already very clearly mentioned in the video, also the linear motors, for precise printing, and more importantly, it's a maintenance free. virtually maintenance-free linear motors. GrabCAD print direct from CAD, native CAD files that can enable you without having to export as a .stl. You'll be able to read your native data, start processing files so that you have success of printing without any file transfer issues. So with controlled heated build chamber, you have better, stronger parts, and more importantly, it also controls the curl and warpage issues. So industrial connectivity, when it comes at every angle, even remotely, you are able to take control of what's happening. And more importantly, Stratus knowledge and technology have played a very, very important role in introducing the F770. So there are all the advancements that have happened over the last 3 decades from the inception of the FDM technology, the patented technology. Today you have the Stratus's knowledge and the technology which have proved for F770 as a great success. Now, while we are looking at most of the areas that we can target, large part 3D printing as all-in-one parts. Now, no more joining, no more sectioning, no more challenges in terms about sectioning a CAD file and then bonding them together because you have a very large build envelope. And what about the quality? Yes, strong, accurate parts. These are made with best-in-class densities. With GrabCAD print, you can also have solid and sparse or selective customization for thick and thin areas. All these are possible to give you a qualitative output. More importantly, when it comes to consistency, yes, it's proven the technology that simply works from Stratus has 100% uptime. Ease of use. As I mentioned again, coming to GrabCAD print, it's a plug and play workflow software. Very, very simple. And more importantly, service offerings. We have global service, and more importantly, we Design Tech are the platinum partners of Stratus. Our engineers have been trained at Stratus facilities in India as well as abroad. So they are there in a day's time to come over and attend to you at a local level. And we have a widespread network of offices all across the country to address customer needs. So great value proposition when it comes to looking at working with ASA. ASA for styrene-based material, which is used predominantly for more aesthetic end-use applications, outdoor applications. That's ideally what we look at. So what are the different value propositions that come along when it comes for production managers, manufacturing engineers, or quite a lot of industrial equipment manufacturers, consumer goods industries, research universities, a whole lot. And all that what matters is those of you who need to have reliability and the ease at which you can work on complex geometries to produce accurate production tools, jigs and fixtures, prototypes, and these are engineering grade materials at a lower cost per part. And that's exactly where we are looking at 3D printing productivity that begins with Stratus F770. Unlike all other large format printers, you could see that the construction of the printer itself, that these are made to perform over a lifetime for that. So delivers high value, whatever investments are made for getting out the most complex parts, functional parts that are very large. 3D printing has been simplified with the introduction of F770 from Stratus. So as I mentioned earlier, like Stratus listens to their customers. We talk about listening to various customers who have been FDM users. Print quality, limitations in mechanical properties, ease of use, printer reliability, large tray size, printer price. So all of these have taken into account, and that has really proven that F770 has been a great introduction that has been introduced on the FDM product portfolio from Stratus. And that's where it all begins with this customer testimony who speak about what the value that they have been able to achieve with the F770. Here's a video.
Introducing Stratus F770. Delivering a large build volume of up to 1 meter in length, high process reliability, and manufacturing floor features at an affordable price. application modeling, over 30 years of experience in its DNA, qualified materials, and extensive global service network. Printing material for the F770 comes in 200 cubic inch material cartridges. Made from recyclable cardboard, whilst utilizing a minor bag to reduce moisture absorption, resulting in stabilized process reliability. Decrease the machine downtime due to material changes, print very large parts, or full trays of small models in one session with a large filament capacity. The F770 is utilizing a vacuum build sheet. This allows the removal of very large parts of the heated oven in a much more convenient and safe manner. The touchscreen graphical user interface makes operating the F770 convenient and easy to learn. Two USB connectors allow for offline and remote operation. The F770 is using proven extruder technology from the Stratasys F series. Combined with manufacturer qualified printing materials to maximize the yield rate. The big build volume of the F770 allows for large parts like this automotive footprint to be printed in original scale and 1 piece, no puzzling required. As long as there is enough previously unutilized area remaining, build sheets can be used on several print jobs. To capitalize on this, models about to be printed can conveniently be placed on the build plate just before starting the job. Fully supporting GrabCAD print and its advanced FDM features is further improving the ease of use of the system. The F770 can fully utilize a very large build volume of 1000 by 610 by 610 millimeters. The chamber is heated at extrusion level, greatly improving reliability on large parts.
So while we talk about a large part, here in contrast, the air conditioning, the white goods manufacturing, they have that large part which has been printed. Now, this particular large part, whether we are looking at air conditioning components that come up, grills, the ducts, housing covers, fans, all these complex geometries are best achieved with the F770 and including the housing. Now here we are looking at a washing machine. So what we look upon here is the large shell covers that can be made, the duct and the draining, the drum housing has been printed. These have been tried and tested with the Indian industries. Today we have pioneered to use the Stratasys FDM technology after having to test their drums for performance. You know, it's a functional evaluation. So what you get to see is that the base part which has been printed with ABS black, that takes up quite a lot of internal assembly components, and that is going to house the entire drum for functional testing. And these are proven time and again with Stratasys F770 for such functional application testings. So the ABS black that has been printed is the base component, that base of the washing machine. You could look at some of the critical features that have been printed in one shot. So what does Stratasys do in their product well before they release the product? Well, they go through various series of field testing. You know, it's been proven for dimensional accuracies. They have to repeatedly check with various types of geometries. And more importantly, it has to be proven time and again that there is an uptime of 99% plus. And more importantly, whatever diagnostic measures have to be taken are addressed well before the products are even being launched. So these are durable equipments that are reliable, more importantly for performance based. So they support quite a lot in terms of industrial equipment manufacturing, whether it is heavy industry, transportation, or consumer product manufacturing. Absolutely no limitation. Now, what are the primary applications that all these industries are using predominantly? You could see that you can make any given complex soft jars for work holding for traditional manufacturing. And we have polymer-based tooling to give shape to metal, press brake tools, 3D print them, hybrid jigs and fixtures, drill jigs, machining fixtures for CNC manufacturing, CNC machining for traditional applications. So what we need to ideally understand here is 3D printing complements the traditional process and supports the traditional manufacturing capabilities. Another case study here, we are looking at a perfect part assembly with excellent accuracy and quality. Now, there's a huge part. This part exceeds more than 600 plus millimeters on its length. And given all these complex features, you could say a 3D printed part with class A surface quality. And more importantly, these are tried and tested for functional evaluations. That's exactly what I mean. Just plug and print. F770 has been tested for reliability over 3,400 hours. And you could see that 4,000 different types of geometries have been tried. 60,000 cubic inches of materials have been tried and tested before the product launch. So, well, soluble support plays a very important role to achieve every detail. Let me reiterate again, and that is truly a game changer with Stratasys. So there is no design limitation. So you have the designs, however complex you generate, they could be made in a single step printing process. Key applications, as I mentioned, large prototype, jigs and fixtures, tooling, soluble cores, you can name them. Tooling for paper pulp molds, thermoforming tools, large format thermoforming tools that requires solid as well as porous areas. Yes, this is the USP that you are looking at when you work with Stratasys additive manufacturing systems. High part quality and very high surface finish in the extrusion principle. So while we look at more applications, sand casting patterns for cope and drag, more importantly, part carriers in the production line. These are defined exactly to the geometry, and as you design them, you'll have large part carriers that can be printed, and more importantly, automation parts, or you name them feeding ducts, end of arm toolings. All these are made and simplified in the manufacturing process using Stratasys F770. So hearing the voice of customers in some of the use cases, we have challenges from various industries, longer lead time, labor intensive, non-reliable, geometry limitation. These are in one step addressed with the F770. Faster iterations begin, hands-free support removal, proven systems. These are proven systems. Any given complex geometry is no limiting factor with the soluble support. So manufacturing floor fixtures. So these are for finished goods, transportation fixtures that have been made. And you could see that on the side walls, there is a cutout with an angular top, which means it's a self-supporting angle that has been well supported with the Stratasys FDM technology. So instead of 2 months, here we have a case study that has been addressed to be printed within 2 days. Reduce the weight from a sheet metal version of this part carrier by 65%. Very similarly, for consumer goods manufacturing, as I mentioned, this is a washing machine based component. Well, with the complexity of the geometries, even traditional processes add a limitation for CNC manufacturing them. Textured armrests, you'll have textures that can be printed. You could see on the brown surface or the black surface, there are textures with FDM. You don't see the lay lines, but textures what you intend in your designs that are accurately and repeatedly reproduced on what you intend to print. Well, when it comes to competition for making large format printing, we have always come across that there is big talk that has been happening in the market, but end of the day, where does it lead to? Are they in a position to even address the accuracy and the precision required to print these vent panels? That's exactly where we have outscored them. Look at the size of the part, 783 millimeter single shot printing. And when it comes to the base part of the washing machine, this is really, really complex. And let's see what the complexities of both these geometries are. When it comes to selective laser sintering, the powder bed fusion, competition doesn't stand by because they have to split, because they don't have such a large build area to support, either in SLA or in SLS. And very difficult to machine the internal channels with curves. And that is the throughput that you have been getting from the F770. So without being challenged for what you have designed. So in comparison to the summary that we have, whether it is the FDM F770, the cost, if it is compared to 100%, even on the F900 of the FDM, it's quite expensive. But that is where the value add is of the introduction of F770. Working with ABS and laser sintered parts are far too very expensive. And more importantly, when it comes to triple F, you need to redesign the part. The existing design cannot be completed because it cannot be supported. So there will be features which are not completed in the print process itself. And CNC, it's impossible to print this, even with multiple settings, not recommended for this geometry. And very similarly for this particular geometry of the automotive hood, well, it's a very large part in comparison to the F770. Even the low-end printers or the CNC, these are not at all possible. And when it comes to the SLA, the service bureaus, far too very expensive. And more importantly, when it compared to the cost of Stratasys F770, is far, far cheaper, quick turnaround time. So thereby, before I conclude, let me tell you, Stratasys offers materials that can enhance repetitiveness in quality and the factor of reliability with Stratasys additive manufacturing systems. That too exclusively with all the 5 technologies. And more importantly, today, in the focus of F770, we are talking about materials, repeatability, and more importantly, the factory integration. Let me reiterate, it's a complementing technology that supports traditional manufacturing. Well, I've come to the end of today's presentation on the F770, and I really look forward to take some questions if there are any.
Yes, thank you, Ganesh sir. Thank you for your presentation. So as I have mentioned earlier, I will be sharing the webinar PPT and the video recording to your registered email ID tomorrow. I will just take the questions one by one. Just a minute, sir.
See, there are a
Yeah. So
couple of
first,
questions in the
yes, there
chat
are a
box.
couple of yes, yes, yes.
Yeah.
There are a couple of questions. So
So
to
I
start
could
with,
see that, yeah, there is from Manish Sharma that I could
yes, yes,
see is,
Manish Sharma, yes.
should I read the question out and answer it?
Any which way, sir, I will do it for you.
Okay.
So the questions will be question is strength is issue with many parts. How do we overcome it? Also, if we work on it, then filling increased, and so it's is the working or the manufacturing time. How to tackle these issues?
Well, Mr. Manish, thanks for coming out with a great question. First of all, let me tell you that when it comes to the strength issues, you need to recall that what is exclusive with Stratasys product line. Here we are stressing upon that it's not just the material or the hardware. It's a complementing technology which comes along with hardware, materials, and the software. Now, strength is definitely an issue when you are working with non-industrial grade 3D printers or the triple F technologies, because the governing aspect here for having high strength and performance does enable 3D printed parts to be functional, to be used for next level of applications, to be used as an end-use part in a product. All this happens if you recall the videos and over the slides that I've been stressing upon. Stratasys FDM technology works with the principle of vacuum enabled heated chamber. So when in the videos that were played, you could see that a large build sheet being located on a build tray, which is held by vacuum, and the doors are sealed and closed when you start beginning to print. So the chamber temperature governs the output's quality. And predominantly while you're looking at lightweighting of parts, we are looking at structures, whether it's going to be complex filigree structures, organic structures. All these are high strength, lightweight. So there are critical case studies I would definitely wish to understand from you on any given pertaining geometry that you are referring to, strength issues. Definitely with Stratasys, if we get to work along with you and even enable you to have a proof of concept printed, you will get to physically evaluate in terms about what you have been doing and what is that you can expect with Stratasys. So I definitely welcome you to get connected with us, and I would be more than happy to address these challenges, because Stratasys is proven over the last 3 decades to produce high strength outputs, and there is no issues or challenges that have been reported. And I wanted to get a feel of what the true Stratasys FDM technology is all about. So we'll get connected.
Right, sir. So we will connect with Mr. Manish Sharma. Will connect with you, and we can understand exactly the issues which you are talking about. And I think accordingly we will take it ahead. So moving on to the next question, sir. We have one question from Mr. Vishwanath, that what is 1-2-3 architecture? What is the advantage of linear motors?
So while we talk about linear motors in the F123 architecture of Stratasys FDM technologies, all the while we have been working with, in the previous part, there have been challenges when it comes to print quality. There have been at times when you pause a print or when you leave the printer without having to load sufficient material, if the materials are less, and then there is an issue that the printer pauses and waits for reloading, what happens is the internal movement of the head along with the tray for layer addition of material has certain challenges. The challenging factors have been the motors were having certain challenges to result in part quality issues that have been addressed with the linear motors to enhance the part quality, though, so that you are not encountering any further challenges. Now, when there is the head movement from the x to the extreme, x minus to x plus, or the y minus to y plus, or the z axis movement, the linear motors play a very, very important role to control exactly the precision movements that are called for without having any backlogs that would result in the part quality or the dimensional accuracy. So linear motors play a very, very important role, and it is very advantageous in the Stratasys product line. And all now, when whatever systems you're seeing on the FDM, you'll have all the linear motors.
Right, sir. So moving on to the next question from Mr. Manohara. So I think he has two questions in line. Uh, so is there any other printer similar to F770 with smaller bed size? The F770 uses proprietary material, right? And open source. If proprietary material, what is the cost of per kg? And also he wants to know how is the speed compared to other FDM printer?
So, Manohara, what I would like to tell you is that the F770 is a technology predominantly working with ABS and ASA, two engineering grades of material, and it's a large format printer. Well, to answer your question in terms about a smaller print build envelope or smaller bed size, yes, there are printers starting from 10 cubic inches going up all the way to 1 meter in size and so on. Now, when you look for open source, open material license, other than the proprietary material, yes, we have machines that come along with open material license, like the Fortis 450 MC. It is far, far advanced in terms about the material portfolio that can work with the Fortis 450 MC. It is a 16-inch x-axis with which you can start working with 16 by 14. And this gives you enablement to work with high performance materials as well. So high performance materials that can be catered for aerospace applications. You have PEG based material, you have nylon based carbon fiber reinforced materials, you have polycarbonate, you have a blend of PC ABS, and a whole lot to talk about. So we'll take up your requirements exclusively in terms of addressing what is that you would be interested more importantly when you're looking at Stratasys FDM as a technology. And in comparison, to address your next question on the aspect of cost per material, as an open source platform, it gives you the privilege to procure any OML material and try to work around with the hardware that comes along for giving you the repeatability and the reliability factor, provided that these materials are again going to answer to your quality needs. Subjective to that, it's an open source material license that comes along with. So it all depends upon with what market value that you're going to pick any given material per kg with respect to the Stratasys material offerings. We can definitely take it offline and have more detailed discussions in terms of the costing of materials. Otherwise, when I have to answer your question, when it comes to speed comparison, the fastest in terms of extrusion principle, 1.43 cubic inches. That's exactly what we talk. Now, it is again subjective to what sort of geometries selection is. Is it going to be solid? Is it going to be sparse or customized and geometry dependent? The speed is far superior with all extrusion principles, and that's exactly where Stratasys stands by.
Right, sir. So moving to next question from Mr. Anjit Pal. Basically, he wants to know what is the soluble support.
Well, soluble support is a material that is a proprietary material of Stratasys from the Stratasys inception of the FDM technology or the introduction of the FDM technology to the world. Stratasys had introduced the soluble support in the FDM line of printers. And now today we have soluble support in PolyJet and various other technologies as well. But as I mentioned, as a proprietary material, the soluble support in principle is used not just for upholding overhang features, but it is exclusively used even in certain high-end applications for thermoset parts, for carbon fiber layup tooling. You make soluble cores with these material to have irregular internal features that can be captured. Carbon fibers can be laid up. So as an exclusive material, soluble support is again a material that is extruded on the FDM technology for the FDM process, which can be laid up layer upon layer in a sparse mode, ideally in a honeycomb structure that gets dissolved when in contact with water. And it's a solution primarily consisting of water, very, very similar to a soap solution that can be drained out post curing FDM parts multiple times. So soluble support is an exclusive material from the Stratasys portfolio that is too good to work with for challenging geometries, that comes along as a proprietary grade of material.
Right, sir. Also, Acha, he has the same question, same related that can 3D printer replace the plastic injection molding? This is the common question which has been asked at almost every webinar, sir.
Well, yeah, correct. Now, thanks again, Anjit. I appreciate that 3D printer replaces the plastic injection mold. Now, look, if I have to briefly give you an overview, injection molding is the best fit when it comes to volumes. There is no doubt about it. Injection molding serves for cost-effective production of parts only if you have large quantity of production parts to be made. But when it comes to 3D printer, 3D printer doesn't support too large a volume, but for limited volume, say for batch quantity manufacturing of a few thousand parts or a few tens of thousands of parts, yes, there is Stratasys technologies like DLP, we have powder bed fusion technology, which is redefined with our SAF, selective absorption fusion, as well as FDM, because the material grades and the limiting factor of the injection molding for quantity, because it takes time, huge investments to fabricate a mold. But whereas with 3D printing, you want to immediately have a batch quantity manufactured starting from day one, maybe depending upon the total build area and the complexity and the overall size of the part, you would be able to decide it is a great value for batch quantity manufacturing. So if I have to put it across in summary, the sweet spot for additive manufacturing is low volume, high complexity. But for injection molding, high volume, lower the complexity. So, well, I
Right,
hope
sir.
if there are any further questions, we would love to take them, or you can
Yes.
also send your questions and reach us out through the
Yeah, we'll
various.
just,
Yeah,
sir, we'll take last question. I think Mr. Vishwanath N has raised his hand. So I will just check if he wants to speak anything. I will just unmute him. Yes, Mr. Vishwanath, I have unmuted you. If you want to ask anything, you can ask directly.
Hello, thanks for the session, and I would like to know what is 1 to 3 architecture, and due to linear motors, is there any benefit in the accuracies of the component produced?
Okay. I think, sir, Ganesh sir has already told you about the 1, 2, 3 architecture and the linear. But if Ganesh sir, if you want to repeat or if you want us to
Okay.
repeat again.
So what happens is linear motors, primarily, as I mentioned, it is for achieving, it is a seamless integration process. When we are working with a linear motor, like we have the benefit of working along so that you have best, or you set upon high quality standards, and you are more reliable in terms about working with linear motors, because in the given process, there is quite a lot of moving components inside, and the moving head assembly, the moving build tray carriage that actually upholds the part. All of these need to be sustainable over a period of time that could govern the quality output. So ideally, the best fit, what has been um, chosen as a component in the 3D printer manufacturing has been the linear motors, because here everything is in principle based on sustainability for over a period of its lifetime for performance. So there is no looking back when it is coming to compromise in terms of the components that are being housed in manufacturing. So Stratasys, with their positive statements and over the years of the factor of reliability, linear motors play a very important role, reason being that it is highly systematic, and more importantly, when it comes to sustainability of the working principle, they perform very, very well, number one. Secondly, your question towards F123 architecture. Now, F123 architecture is in principle the advancements of the office shared systems. So with the same principle, the F770 has been introduced. The office shared systems, usually we used to talk about a desktop printer or office shared systems, usually coming with only one single material to work with. The architecture in the F123 principle is about, an intuitive user interface, multi-materials to select and choose subjective to your applications, and more importantly, larger and enhanced build envelope areas. And primarily, when we talk about remote monitoring and MT Connect, all these are under the F123 architecture, which are nothing but advancement in the features of the 3D printers that give better proven reliability, and more importantly, addressing to work on customers' needs when there are different material choices. Yes, you have a selection of materials to be made with. And the advancement in the interface that comes along for placing a job, for printing a job, or for monitoring a job at a given layer, all these are possible with the advancement. So that's exactly what we mean about the F123 architecture all about.
Okay, okay. Thanks for the information.
Thank you, Mr. Vishwanath. So Ganesh sir, we have last question from Mr. G.K. Venugopal. What is the automotive hood product life cycle after 3D printing?
So what is the automotive hood? Now, the
Yeah.
automotive hood that we are talking about, the product like cycle, like today when we talk about any particular component, the automotive hood has to have a certain performance. Now, what are these performance carried out for? Primarily, they have to have a fit form evaluation, and these hood are so very complex in nature. With a single step advancement in 3D printing, that you get to realize fitment evaluations, form evaluations, and certain limited functional evaluations. Now, primarily, if you're looking to print the same hood using a nylon 12 CF material for having functional evaluations and field testings that needs to be carried out for multiple cycles, for multiple days, and in rigorous environments like test beds, it has to be fixed on a vehicle and tested. So the choice of material selection plays a very important role. Here we are talking about working with ABS as a material. Yes, to a limited set of functional evaluation, they answer very well, but these are not product lifecycle parts that go on any automotive. These are for initial product developments and limited functional testings with ABS. But if the choice of extended functional testings are called for, then we look upon the material selection itself with a carbon reinforced material, or for a high performance grade of material that can withstand higher temperatures and performance rigors that are called for during testings.
Sir, so I think there are no more questions, and I think we can. It's good to conclude. So once again, thank you, Ganesh sir. Thank you for your presentation as always. Also, thank you everyone for attending this webinar. So see you next time. For till the next time, thank you and bye from our side.
Thank you
And
very
have a
much,
great evening.
Pranjit, and thank you all of you who have come out with very interesting questions. Until the next time we meet, big thank you to you all, and stay connected and do let us know how we can work along together to address most of your challenging needs in terms of adapting to use 3D printing, or with existing 3D printers, whatever challenges you're facing. We would love to come and meet you and support you with proof of concepts. So many thanks till the time we meet again. Goodbye.